cosines, you've got three versions of it here based on which sides you have. As you start to apply this, you'll notice that they're kind of similar. If you have an a squared here, it's a capital A here. If you have b squared and c squared, it's b and c here. If you have a b here, capital B here. So it kind of, it'll be easier to apply than it really looks whenever we get into it. So, law of cosines, you're going to use this basically when you cannot set up the law of sines. So you're going to use that when you have two sides and the angle in between it. Because if you have a triangle, and let's say that this is 50 degrees, and that this is 5, and this is 7, and you're looking for this angle over here, let's say you're looking for the side over here. If you try to set it up, you'll have sine 50 over x equals sine of, you don't know any more angles over a side, so you've got two variables in the problem. So it's not, law of sines will not work in this case. So law of sines is going to be used whenever you have two sides in the included angle. That would be a side angle side situation. And if you think back to proving triangles congruent, was there a side angle side postulate? There was. All right. The other time you will use this is when you have all three sides and no angles. Side, 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 was that a postulate that we had when we did proving triangles congruent? It was also. So here's your good news about this. For law of cosines, there is no ambiguous case. Right? It is not possible to have that because you can't use this in an angle side side situation. So, so law of cosines, there is no ambiguous case. We do not have to check for it. So I think that makes it much easier to do. I know that as you guys were doing the homework yesterday, you got those first two were ambiguous case, and it's so much work, especially if you got to solve the whole triangle to get that. So I always hate those. I always like the ones where you have no possible triangle because you just get to quit after you figure those out. But with law of cosines, one of the things I think makes it easier is that you do not have to do ambiguous case for this. The other thing I think is easier is when you have a problem that is side angle side. I think it's pretty easy to solve. So in this case, we want to find side A, and we know angle A. So we would use the one that's A squared equals B squared plus C squared minus 2BC cosine of A. That's our formula that we're going to use. And so we'll plug in, well, our A we're not going to plug in because we don't know A. That's what we're looking for. So side B, what is side B for this problem? 12. Now, does it matter, really, which one's B and which one's C? You're adding these together. You're multiplying here. Does the order of addition or multiplication matter? It doesn't. So if you said it was 15 when side B is really 12, it doesn't make a difference. These just need to be the two other sides that you have, right? So technically B is 12, but if you put 15 instead, you're still going to get the right answer. And then 15 is side C, and minus 2 times 12 times 15. And we'll have cosine of angle A, which is 98. Here is what I like so much about these problems. This calculator, you can just type it in as it is. You don't have to do it piece by piece. You could do it piece by piece, but you don't have to. If you just do 12 squared plus 15 squared minus 2 times 12 times 15 times cosine 98, it should do all of that right. It can handle that order of operations and those. So we get A squared equals 419.102. And the biggest mistake I see kids make on law of cosine problems like this is they leave that as their answer. Would that make any sense? 12, 15, and 419.102. That'd be way too big, right? So always ask yourself once you get your answer if it seems reasonable, because that would not, and it'll help you remember that what have you got to do to get the A here? Square root. So you want to square root this number. So you can do second square root and do second negative to get the answer so you don't have to round off. And hit enter. And so we'll get A equals 20.472. Does that seem reasonable? Yes, that's much better. That if the two smaller sides, if you add the two smaller sides together, it has to be bigger than the third side. So like 12, the biggest the A could be would be 27. Well, it couldn't be 27 because then it'd basically be a straight line. But like if you think, if you had this side was 35 and this side was 12 and this side was 15, they would never meet in the middle, right? Because they would, like even if you hinged them down here, they're not going to touch, so they would never touch. So the two smaller sides, if you add them together, the third side has to be smaller than that. So that's a good way to check to make sure what you've got is reasonable. Okay? Questions on one? All right. Here's example 2. We've got like an application problem here. I like this problem. I think it seems kind of like, crime scene investigator sort of ish, although it's simplified down some. You have to make, those cars could be carrying dead bodies. Yeah. So, yes. Or large amounts of drugs. And we might need to track them down. You think they're going to slow it down? Well, somehow we know how fast they're going, though. Maybe that's top speed for your minivan full of cocaine there. I'm recording this. I better hush. All right. So we have car A and B leave the same point at the same time, right? And car A travels north on a straight road at 60 miles per hour, and car B travels 20 degrees south of east on a straight road at 45 miles per hour. After 2 hours, how far apart are the cars? So let's say that, car A that's done something wrong is headed north, and car B, that is the police chasing them, thinks that they've gone this other direction, and they start going this other direction, and then we want to know how far off track you are at the end. A lot of stuff we have to do here, we have to oversimplify. Roads don't travel perfectly north or perfectly straight. Probably car A doesn't go exactly 60 miles per hour the whole time. They might speed up or slow down for traffic, right? So we have to sort of oversimplify, but you can get like the basics of where this might be helpful in some sort of sense. So the easiest place to have them sort of start from is have them both start from what would be the origin, right? So if we're thinking north, south, east, and west, we got north, south, west, east here. And so car A, we're going to have them both start right here. Car A is going to travel north on a straight road like this. And they go 60 miles per hour for 2 hours. How far do they travel? 60 miles per hour for 2 hours. 120. Yeah, 120. All right. Car B is a little bit more difficult because for car B, they're going to travel 20 degrees south of east. So this is something we're going to do a lot whenever we do vectors. Here comes Coach Wood. How you doing, Coach Wood? We are. Justice has suggested that this this car is a minivan full of cocaine we're trying to catch here. Because I like him. I keep the kids I like towards the front, and the kids I don't like towards the back, so I don't have to deal with them. Not really. I do. I either put you in the back because I trust you, or because I don't like you. Occasionally, I have had kids that I put in the back because they drive me crazy, and I can't have them up here close. You're pretty close up here. Oh no. Oh, trust you? No. You're the one that said the minivan's full of cocaine. So, but all right. So I like all of you guys. You guys are nice kids. I don't have any of you I put in the back because I don't like you. Last semester I had a couple in the back because I just couldn't have them that close to me, listening to their every comment. I need them to be away. So car B is 20 degrees south of east, right? So that means east is the main direction that they're going, and you're going 20 degrees to the south of that. So that would look like this, right? And this, I probably didn't draw that quite small. That would be 20 degrees. And if car B travels 45 miles per hour for 2 hours, then how far has it traveled? 90 miles right here. Okay. And so our question is, how far apart are they? So we want to know this distance right here. Now I realize this car probably could not do that. If it was a helicopter, that'd make a better problem, wouldn't it? Like this helicopter is going down this highway thinking they went this way. And the helicopter, when they get a tip there up here, the helicopter really could go straight in that direction. Helicopter go a lot faster too. I'm going to change this problem next time. You like cars better? I will somewhat agree with you. I'm not hurrying up to get on a helicopter anytime soon. So, yeah. Oh. Yeah. Yeah. It looked like it was going up, but with no, like an alien had just, yeah. I'm sorry to those who have to watch these notes at home. Fast forward through this part. So, yeah. This won't pick up that. So, yeah. Anyway, so besides our reasonable fear of helicopters here, let's see. I don't really need this here. All right, so I don't know why half of that just disappeared. Well, I'm just going to have to live with that E right there. I wanted to give myself more. All right, so right now, our only problem is that we do not have the angle inside of the triangle. But we can find it pretty easily. What would it be? Right, that right angle plus that 20-degree angle. So right here, this whole angle is 110. All right, so now we're ready to go. All right. Okay, so what we want to do here, erase that. I don't know why it won't let me erase that. I want to make myself some room to do the problem over here, but it's not allowing that. So we want to find x. And so that means that the angle across from x, that 110, which is the one that we know, that's going to go on the end. We'll have our cosine 110. It does not matter which one is A and which one is B as far as your 120 and your 90. So you'll have 120 squared plus 90 squared minus 2 times 120 times 90, and then cosine of 110. And so you'll just get your calculator and type all of that in. And we get this huge number, and we hopefully know that would not be a reasonable answer. So we're not done. All right, what's our last step here? Square roots. And so we get x equals 172.880 miles. Okay, which seems fairly reasonable, because if they were going opposite directions, they'd be 210 miles apart. That's definitely the longest side of the triangle, so it seems like a pretty reasonable answer. Okay, questions? All right, here's our, I think this is the last one, isn't it? Law of cosines problems are a little more difficult whenever you are looking for, whenever you have all three sides. I still think that it's much better than having an ambiguous case law of sines problem, but it is more difficult than the first two that we did. So if we've got triangle x, y, z, so x, y, and z, they tell us side x is 14, side y is 19, side z is 22. Okay, so we need to find, we got to find all three of the angles here. So it really does not matter which one you pick to find first. There's not one easier than the other. So Nathan, which one do you want to find, x, y, or z? Y. Okay, so if we're going to find y first, then that means whenever we do this problem, I need to have, like on the end here, I'll have cosine of y. And that means over here on this side, the side across from y has to be the one that you have over here. So we'll have 19 squared. And 22 and 14 are our a and b. It doesn't matter which one, or you can call them x and z here. It doesn't matter which one's which. So we'll have 22 squared plus 14 squared minus 2 times 22 times 14. This one's a little harder to solve because you can't just type it into your calculator, because your cosine y is over here on the side. You are going to use your calculator to help you, but you can't just go straight to the answer like we did the last one. So 19 squared would be 361. 22 squared is 484. 14 squared is at 289. 196. And then 2 times 22 times 4, and 14. That gives you 616 cosine y. Now, the biggest mistake I see kids make on these problems is they'll do this. They'll take 484 plus 196 minus 616. All right, and get 64 cosine y. cannot do that because 616 has a cosine y with it. It cannot be combined with the other numbers. All right, this is like having a 616x. You cannot combine a 5 and a 5x together. They're not like terms. So you got to leave this part right here. You got to leave it alone until the end of the problem. So you want to add the 484 and the 196 together. And you could actually have done that on the first step if you had wanted to. Done the 22 squared plus 14 squared all together. So you get 361 equals 680 plus 196. Oh no, not plus 196. Minus 616 cosine y. Alright, you're trying to get that y by itself, which means you got to get rid of the 680 first, so you're going to subtract it off. So, 361 minus 680 is going to be negative 319. That's going to give us negative 616 cosine y. What would we do next? Divide by negative 616. So you have 0.51787 equals cosine y. And last step, how do we get rid of cosine? Inverse cosine. So inverse cosine of that answer, and we'll get y equals 58.81137. There. I said 767. Round it off to 3 places if you want. Okay, questions on finding y? It takes a little bit longer to find that. So now that we found y, this problem did so we had to solve the triangle. We just found this is 58.811 degrees. So we've got to find x and we've got to find z. So we could go back and do that whole thing that we just did over again, but with x or z. Or, now that we have this angle, we can use law of sines, which I think is a little bit faster than doing this whole thing over again. So, since we have 58.811, we can say sine of 58.811 degrees over 19 equals sine of, let's see, Hannah, you will find x or z. Okay, so we find x, sine x over 14. I'm only finding x because Hannah told me to. You could find z first. It doesn't matter. Okay. All right, so we're going to cross multiply. So we'll have 19 sine x equals 14 sine 58.811. And if we're solving this, we need to divide by 19. So sine x equals, on our calculator, we're going to type that in, so 14 sine 58 point, actually, let's do this, 14 sine second answer so that we don't have to type that whole thing in, and then divide by 19. So that gives you 0.63034. What's the last step here? Inverse sine. Inverse sine of the answer. So we'll get x equals 39.076 degrees there. This is an angle side-side problem, and it's not because we do know all 3 sides. If you did law of cosines first, the second one should not be ambiguous unless you get an angle that just really doesn't make sense. Like if this angle was like 125, and then we got an angle over here that was like, 85 or something, or it'd probably be more like 185, 175 or something. If you got an angle that really doesn't make sense, it's possible that it's ambiguous, but I don't think you'll see any problems where you really have to check for that if you started with all cosines. So we do have to find z, but z is not too bad. For z, we're just going to do 180 minus 58.811 minus 39.076. And when we do that, well, you get 82.113 degrees. Alright, so you have your x, y, and z. So you're finally finished. Okay. Alright, questions? Alright, your assignment for this is going to be page 331, 11, 13, 15, 17, 18, 27, 29. Actually, those first ones are, I'm going to take off 11, just do 13. Because those first ones are solving the triangle, the first four are, and sometimes those get a little long just because you have to find all the sides.